I have here a demonstration of how the new physics works, which is very elegant, but it's so simple you can easily do it at home yourself with some Polaroid sunglasses. Before I show it to you, let me remind you of how Polaroid works. You remember that light is a wave, but it's a transverse wave. If I have light moving along in this direction, the electric field is actually oscillating perpendicular to that direction, either up and down like that, or sideways in and out of the blackboard, or oblique to that direction. In fact, in an ordinary incandescent light bulb, the light that comes out is oscillating in all possible directions perpendicular to the direction that the light is going in. The direction in which the light is oscillating is called its polarization, and ordinary light is unpolarized. What Polaroid does is to permit through the Polaroid filter only one direction of oscillation of the electromagnetic field. Let me try to illustrate the point to you. Here I have a source of light, and you can see the light on the screen. And this is a piece of Polaroid glass. If I put the Polaroid glass into the beam, the light gets a little bit dimmer. Part of that, of course, is because the glass is dirty, but most of it is because the glass lets through only one polarization of light. I can turn the direction of polarization by turning this handle, but when I do that, you don't see anything happening on the screen because your eye is insensitive to the polarization of light. In order to show you that that light is polarized, I must use a second piece of Polaroid in the beam. Let me do that. I'll put here a second piece of Polaroid. Now the light becomes dimmer again, but this time it really is only because it's a dirty piece of glass. This piece of Polaroid is aligned in the same direction as the first piece, and so everything that gets through the first piece also gets through the second piece. To show you how Polaroid works, I must rotate the direction of the second piece of glass. And when I do it, as you can see, the light gets dimmer and dimmer and dimmer until nothing gets through at all. What's happening now is that only light that's polarized up and down is getting through the first piece of glass. The second piece of glass will transmit only light that's polarized horizontally, and there isn't any of that. And so nothing gets through, and the screen is blank. What's a little more difficult to understand is what happens when the second one is oblique, like that. Then part of the light gets through. Because the light comes in, it's waving up and down. This one allows light that's waving this way, but each vector has a component along that direction, and that part of the vector, that part of the wave gets through. So that's the explanation of how Polaroid works, and it's very easy to understand so long as we believe that light is a wave. But remember, light is also a particle, and there must be a particle explanation of how this occurs as well. So let me tell you how that works. The problem here is that I can't say that part of the light gets through the second filter when it's oblique, because a particle either gets through or it doesn't. Every photon either comes through or doesn't get through. So here is the way it works. The photons come along, the light particles come along to the first filter. And the first filter says, listen guys, every one of you is either polarized up and down or sideways. Nothing else is permitted. But you're polarized up and down or sideways with some probability. Half of you are up and down, and half of you are sideways. Then the light gets through the first one, the ones that are up and down, and all the sideways photons get stopped. Now between the two, I've only got photons that are polarized up and down. This one, as long as it's in the sideways direction like this, says, you guys are all up and down, I only permit sideways photons through, so nothing gets through. If I turn it up like this, it says, you guys are all up and down, and I let up and down photons through, so they all get through, and you can see the light on the screen. The tricky part happens when I turn it in the oblique direction like that. Because now this says, listen guys, you thought you were all up and down, but that's not true. Everybody has got to be either oblique this way or oblique that way with some probability. And you thought you were up and down only because half of you are this way and half of you are that way. And he lets through those that are polarized this way. That's the particle explanation of Polaroid. Now I'd like to try one more experiment with you. I'm going to turn this Polaroid so that nothing gets through. And then I'm going to take this Polaroid here, a third piece, and put it at an oblique angle to the other two. This one is up and down, this one is horizontal, and this one is oblique. And I'm going to put the oblique Polaroid between the other two. Now what will happen is the following. Only up and down photons get through the first one. They get to the oblique one, and he says, you're not up and down. You have a 50% probability of being oblique this way and getting through, 50% probability of being oblique that way and not getting through. The ones that are this way get through, and they get to this guy. And this guy says, you guys all think that you're oblique this way, but you aren't. Each one of you has a 50% probability of being horizontal and getting through, and each one has a 50% probability of being vertical and not getting through. So the horizontal ones get through. But that means that the beam of light will reappear on the screen. You really believe that's going to happen? A scientist has to be prepared to make predictions. So let's see what your predictions are. How many of you think the light beam is going to reappear on the screen? Raise your hands. Let me see. How many think that it won't reappear on the screen? Okay. I've got all your names written down. Let's try the experiment. I'm going to take this and put it back into the light beam, and I claim the light will reappear on the screen. You ready? And there it is. And that is the essence of the way the new physics works.